to today's lecture. Our topic for today is slope or gradient of a straight line. The slope of a straight line is a number that shows how steep the line is. Okay, so if you look at these three lines, so the word steep here is simply means how sharply a line either rises, or falls. If you look at these three lines, you agree with me that this line BC, okay, in fact is the steepest, okay, compared to this other line TS and line AB. So because this line BC is the steepest, it will mean that line BC will have what? A bigger slope compared to line TS and line AB. So we want to now learn how to calculate such slope, how to get that number, the number we're talking about. Now, consider this diagram. This is a line, call it line AB. Line AB. On this line, there are 2 points. Point P1, we coordinate x1, y1. Point P2, we coordinate x2, y2. Okay. Now, from these 2 points, we join them and we get the point, this third point. We coordinate x2, y1. We want to now learn how to find the slope of this straight line. We want to now know what that number that tells us how steep this line AB is. The distance from this point to this point we call what? Change in what? In y. Change in y. And what is change in y? Change in y is what? y2 minus what? y1. Because this is from y1 to y2. y2 minus y1. And P1 to this other point, I can call this point P3 if you want, is what? A change in x. And that change in x is what? x2 minus x1 is x2 minus x1. Okay. Now another way of looking at this change in y is by saying from P3 to P2 we say is rise. We say rise. And from P1 to P3 we say what? Run. So that our slope M of that straight line is simply the change in y divided by the change in x. Another way of saying it is that slope M is equal to rise. And rise simply means a change in y, because rise means from y1 to y2 over run. And what is run? Run means a change in x. That means from x1 to x2. However, whichever one you use is the same. And this is equal to what? Change in y or rise is what? y2 minus y1 all over change in x or run is what? x2 minus x1. So we see that the slope M of this straight line is equal to what? y2 minus y1 all over x2 minus x1. So you take note of this result. But in practice, when we want to find the slope of a straight line, we don't necessarily have to draw this triangle. All we have to do is, once we know 2 points of that line, like P1 and P2, we can employ this formula directly. So that the slope is y2 minus y1 all over what? x2 minus x1. And I should point out here that if you choose to use this other point here as your x2, y2, and here as your x1, y1, that would not change the value of your slope. Another point I want to make is, if you choose to make this triangle smaller by choosing two other points, that again will not affect the value of our slope. We will now take a few examples to illustrate what I have said, what I have discussed so far. Example: sketch the lines through the following pairs of points and find their slopes. The first point is A 2,5 and B minus 2, and minus 1. The second pair of points, A minus 1, 4, B 3, 2. The third pair of points, A 4, 3, B minus 2, 3. And the fourth point, A 4, minus 1, and B 4, 4. So we shall look at each of them. For the first one, A 2, 5, and B minus 2 and minus 1. I have sketched the diagram, the line already. So 2, 5, 2, 5 is here. And then negative 2 and negative 1, negative 2 and negative 1 is here. So if I join these 2 points, I get a straight line, which I call line AB. We have to find the slope. So the slope M is what? Y2 minus Y1 over X2 minus what? Minus X1. And what does this give us? So this is my X1, Y1, and then X2, Y2. If you like, you can call this point X1, Y1 and call this other point X2, Y2. You get the same slope. So my Y2, like I said, X1, Y1, X2, Y2. So my Y2 is negative 1, minus my Y1 is 5, all over my X2 is negative 2, and my X1 is 2. And this gives me negative 6 over negative 4. And that is nothing but what? 3 over 2. So the slope of this line, line AB, is 3 over 2. Very quickly, let us switch the point and see if we'll arrive at the same slope. We had used this as a what? X1, Y1 and X2, Y2. Is that correct? Yes. Let us switch and use this as X1, Y1, X2, Y2. So our slope M would be, again, Y2 minus Y1 over X2 minus X1. But this time we're having X1, Y1 and then X2, Y2. So our Y2 is 5 minus Y1 is negative 1. So that is plus 1 here, all over our X2 is 2 minus our X1 is negative 2. So that is 2 plus 2. And this gives us 6 over 4, which again is 3 over 2. We have just demonstrated here that the choice of X1, Y1 and X2, Y2 in finding the slope of a straight line is immaterial. Okay, for the second point, negative 1, 4 and 3, 2. Here is the line again. Minus 1 and 4, minus 1 and 4 is at this point. 3 and 2. 3 and 2 at this point. I join with a straight line. Before I go further, I'd like to make a comment here. Now you observe that this slope has a positive value, right? Because this is positive 3 over 2. Now the comment I wish to make here is that for all lines that are rising, okay, rising lines are lines you draw from left to right. For all rising lines, the slopes are always what? Positive. So we say that rising lines always have what? Positive what? Slopes. Take note of that. Whenever a line rises, the slope must be what? Positive. So here, slope M again is Y2 minus Y1 over X2 minus what? X1. So you choose. So I want to take X1, Y1, X2, Y2. So X1, Y1, X2, Y2. My Y2 is 4 minus my Y1 is 2 over my X2 is minus 1 minus my X1 is 3. And that gives me what? 2 over negative 4. That is equal to negative 1 over 2. The remark again I want to make here is that for all falling lines, that all falling lines have what? Negative slopes. So all falling lines have what? Negative what? Slopes. Whenever a line falls from right or from left to right, that line must have what? A negative slope. Now for the third example, we have the point 4, 3, negative 2 and 3. So we plot. So 4, 3, 4 and 3 is here. And then the other point is what? Negative 2 and 3 is here. So we put the line. And what do we see here? That this line is what? A horizontal line, because the line is parallel to the x-axis. All right, let's find the slope and see what happens. So slope again, m, is y2 minus y1 over x2 minus what? Minus x1. This is equal to x1 y1, x2 y2. y2 is 3 minus y1 is 3 all over x2 is 4 minus x1 is negative 2. So that is plus 2. That gives us 0 over 6. And what is 0 over 6? 0 over 6 is what? Is 0. Now we make a comment, a remark here again, that the slope of all horizontal lines is what? Is 0. That horizontal lines that are parallel to the x-axis always have what? A slope of what? 0. And lastly, for the last point, 4, 1 and then 4, 4. So 4, negative 1 rather. 4, negative 1 is this point. 4, 4 is this point. We join. We observe that the line here, line AB, this time around is vertical and is parallel to the y-axis. Let us see what the slope will be. So the slope m is y2 minus y1 over x2 minus what? Minus x1. So I want to take, this is x1 y1, x2 y2. So this gives me my y2 is minus 1 minus my y1 is 4 minus 4 all over my x2 is 4 minus my x1 is 4. This gives us negative what? 5 over what? 0. And we know that in mathematics, division by 0 is not defined, right? So we say that the slope m is what? Undefined. The slope m is undefined. Now the remark we make here is that the slope of all vertical lines is what? Undefined. It's undefined. Okay. So in our next class, we shall look at parallel lines.